Cool. Wow. Thanks for having us here today. We're happy to present to you today a couple of insights on our data platform, data science journey over the last 2.5 years here at BMW. We're happy to present on behalf of the BMW Group what we've built. We'll show, besides an introduction of our department and the BMW Group IT, a couple of insights to the platform, a couple of use cases, and we're going to conclude that by a couple of challenges that we'll be tackling in 2018. We are, first of all, it's me, Josef. I'm data scientist at the BMW Group, joined 2 years ago. I'm an Austrian immigrant to Munich, born and raised in Salzburg. I have to disappoint the Viennese colleagues. I'm not a Rapid Wien or Austria Wien fan. Sorry to say that. I'm more of a FC Bayern Munich fan. Hand over to you now, Tobias.
Yes, and I'm Tobias. I'm almost an Austrian, so I grew up close to the Lake of Chiemsee. Worked for 5 years in the beautiful Salzburg and Innsbruck, but I needed to switch back to Munich and to the company where a Munich guy needs to be, actually. So BMW, didn't regret that I joined. So I joined the group 3 years ago, helped a bit earlier than Josef to build up our data platform, to start the data journey that we are currently in, where we're progressing. I'm the lead platform architect, so with my team we built up a platform. We will present in the next 5-10 minutes. I will show you what we built, why we're doing what we're doing, and then Josef will jump into the more interesting parts and talking about the use cases and the real applications, and the touch points for you as a customer where you really see what we are doing with data and what's the benefit for you. So to understand what we're doing and to understand the scale on what we're operating, it's always good to see how widespread we are across the globe with the BMW Group IT. And actually, those are also the main locations where we are doing research, or we are building the applications, operating the applications that we are building. So we both are from the headquarters, which is of course located in Munich, not in the nice and fancy towers, but close to it. We are almost 3,500 employees in Munich in the IT sector, but we have smaller locations in other parts of the world as well. So we are very largely working together with US colleagues and China colleagues. And there are, of course, some specialities when it comes to legal restrictions when you're doing big data, or when you want to do things on data, you need to do the things in the countries. We are also especially having tech offices in China and in the US, where we're doing sort of R&D, working together with the guy from the Bay Area, but also in China doing research with clever and good guys there. And also we have locations in the southern part of the world, like South Africa and Mexico. So when it comes to the core part of the talk, I at the BMW Group, or Big Data and Machine Learning at the BMW Group, there are two major initiatives which are doing or dealing with those topics. The one is, and I have to give a disclaimer, is about autonomous driving, and we are not really doing a lot of that. So a business department is driving this topic. And the rest of the talk is only about the second initiative. And we both, Josef and I, are part of the central IT group, which is responsible and dedicated for and to do big data, machine learning, and AI applications along the other parts of the value chain of the BMW Group. So this means we're doing marketing projects, we're doing projects in production logistics, we're doing customer projects, but we're also doing and operating on data from the test fleet, and other initiatives at the group. So when it comes down to the technical setup where we're operating, and which we built up starting, I guess, approximately 3 years ago, we are operating on-premise data platforms in the major hubs, in the EMEA region, in Munich in Germany, which are quite big and impressive setup, a couple of hundred of servers, hosting at the moment 2 petabytes of data assets, projected to grow to 100 petabytes in the next 3, 4, 5 years. And as I said already before, we are mainly working, and these are the data drivers, on vehicle test data. So vehicle, and Josef will talk about this, generates a lot of data in only one drive in a couple of hours. We are operating on a lot of production IoT data, and customer data and other data from digital touchpoints is the third and minor component. So you might ask yourself here, so BMW as a group starting a big data journey, so what is the real point, and what is different to maybe things that a company like BMW did with data 3 to 4, 5, 10 years ago? So the major thing that we with our initiative try to enable is enabling the linkage of data and actually generating value based on the linkage. So bringing together the test drive data with customer interaction data, with production data, and basically generating new insights which can be leveraged the whole production chain and the whole life cycle of a car, even when it's in your hand. Second thing which we try to do is to use data in different contexts. It hasn't been used before. So previously, as every company, many departments were focused on just their assets, just their part of the production chain or the value chain. But we are trying to use data from different parts of the value chain, bringing it together to generate new insights. And of course, we did build up technologies and platforms which allow us to use data in a much different way, enabling new business models, like you see with the Ubers and others, and Josef will talk about that, which are only driven by data, which you cannot do without the data. And of course, we're leveraging the historic data much more than we could previously because of the data sizes and the price to store and process the data. So when it comes back to us, so we are, as I said, part of the central IT department. We grew up approximately 200 people, and the mission of us is threefold, actually. First mission is, or was, to build up a big data platform which can be used globally, and AI services on top of it that enable all the things that I told you before, and Josef will go into that as well. Second mission that we have is to build up the BMW data lake. So build up one central location which can be used globally around the globe, in which we have data from different business departments, which can be used by data scientists and business analysts along the whole group, and also enabling and driving new businesses and new use cases on top of it. And the third mission is to really establish and grow AI at BMW Group. So we started 3 years ago as a small incubator, I would say. I was the 15th employee, I guess, in the department. It was quite impressive to see how we grew. So we started up with smaller projects, like projects where we proved the value of using data and the technologies to use data. And from that, we really grew. You might ask, what are the 100 people doing? So we are really a mixture of data engineers, data scientists, software engineers, full stack developers that really build and operate the platform that we're using, and guys that use the data in combination with people from the business departments and build the applications. So how are we doing projects? So on the previous slide, it was shown that we are doing approximately 100 and more projects per year. This can be smaller ones and bigger ones, like initiatives that run for a couple of months. We typically start with an engagement with the business department, with the owners of the data. This might be missing in the process. And from that, we are starting a so-called discovery project, which is a small phase where we try to prove in 10 business days that either data has value, that using the data in the way that we want to use it has value, or that using another technology that wasn't tried before with the data, or another model, that it has value. When we're able to prove that, it either goes into a longer prototype phase, 2 to 3 months or longer, or we go into the scale-out phase, build it out, roll it out to production in the different processes, and then from that, the DevOps operation model starts. So coming to the platform where we're doing most things that we do. So when you are building a platform for a company or for an enterprise like BMW, you have to think about in a bigger scale. I would say it's not about just the technical requirements where you have I need this data from the source system. I have this data in an event hub. I need to process this in a batch mode or a real-time mode. Might think of technologies like Flink, Kafka Stream, Spark Streaming, which you need to enable. You need to persist it in some way, and you need to serve this to other applications or to data scientists. And the scale we are really operating is not just a couple of users, but it's hundreds of users. So we have a couple of hundreds of users already on the platform, which are engineers, but also business departments. We have a dozen of technical tenants that are really doing stuff on the data on the platform. Important, but sometimes also a bit boring is that we have sensitive assets. So really assets which are of high value and which need to be secured in a proper way. We have thousands of processes. I don't know how much of you worked with Hadoop before or other technologies, and the fun is only coming when you have, not just hundreds of processes, but thousands all of the time. Platform and technologies need to operate 24/7. Close to zero downtime is possible because of the integration in other critical processes. And you face, of course, when you try to build these platforms with challenges like, the availability needs to be close to 100% for some parts of the platform. Our goal is basically to automate everything, what we're doing from deployment of the whole platform up to the deployment and release of applications. When it comes to the platform, this is the part where I can talk most about it. We try to automate everything. We try to have a 100% test coverage for everything what we're doing, monitor extremely, and doing continuous integration for everything that we are basically releasing to production. When it comes to the concrete local architecture of the platform, so we started off 3 years ago with a traditional Hadoop architecture, on-premise physical bare metal servers, but we're now going to a sort of, the buzzword would be a hyper-converged platform, which is sort of cloud native. So we're really eagerly looking forward to the next version of Hadoop, which allows much more container usage, where we can basically allow data scientists to build containers, run their things in containers on Kubernetes or OpenShift platforms in their lab or integration test environments, but then scale them out to a distributed and large-scale environment on our platform. We need to enable this, and we enabled this already for running on different infrastructures, and the goal here is as well to start with basically on-premise, to start with in the public cloud, but to migrate seamlessly either from on-premise in the cloud or the other way around. Thing we're building and build is multi-tiered, so meaning you have the possibility to have to process this in a higher speed with higher SLAs, but also to process it in tiers which are cheap for storage or don't guarantee the SLAs. And of course, and this is important for Josef as well, and Josef will talk about the use cases, we try to support deep learning as well as machine learning. So we have a GPU stack besides the platform, and soon integrated in the core platform as well, which allows to do deep learning, image analysis, video analysis, and other things, but also operate on plain structured data. So Josef, your part.
Stage is mine. Okay, very good. So if we talk about use cases at BMW, I'll mainly talk about connected vehicle use cases. We have a lot more, like for example, in after sales, we have use cases, as Toby outlined before, in manufacturing, in logistics. So there's a wide area of use cases that we're operating on. However, I'll mainly talk about connected vehicle use cases. And as part of that, if we look at the history, the legacy of our BMW Connected Drive backend system, which started actually in 2001. I don't know, who of you is born after 2001? There might be people here. No, I don't see anybody. But evidently, there's a history of connected drive backend components that has been built up, and therefore we have a wide area of backend systems today that basically build the foundation for all the intelligent functions that you see today inside of the cars. As one of the first interesting use cases, and I'd like to outline here, that we currently, as of today, have a connected fleet of 9 million vehicles that dispatch data on a regular basis. We've started to embark on the topic of parking services roughly 3 years ago, where we kicked that off with a research project. And now with the introduction of last year's new 5 Series, Some people might notice if they own a new 5 Series, which if you do, you're very fortunate. It's a great car. Then it's already capable of giving you for a couple of German cities, like for example for Munich, Hamburg, Berlin, Cologne, Düsseldorf, all these larger cities in Germany, an estimation of which kind of parking slots are free. And I think this is one of the prime examples that show how historic data and real-time data, together with clever algorithms, can be used in order to make our customers' lives easier. Voice assistants, well, this is a huge topic for us as well. If you look at our cooperation with Nuance, which is a speech-to-text provider, not only that, they are building up a bot framework now as well. We have embarked on that journey for a long time now, and in the reign of Siri, Google Home, the other kind of folks that you see out there, Alexa, for example, from Amazon, they're pushing the topic very hard, and so do we as well. So we have announced late 2017 that we will bring Alexa into the car, which we actually have seen with a couple of customers bringing their Echoes and Echo Dots into the cup holders of the cars. So there's evidently a need for that. And well, Alexa is only one part, so it's basically something we buy off the shelf. But there's another direction that we are embarking on, and that is using data in order to make your car more intelligent. Besides, for example, asking your BMW, what does the yellow light in my cockpit mean? We want to head towards an automation of features such as the smart seat heating or a smart climate control, where we learn your preferences, such as Google Nest does with the home heating system. So this is one of the interesting topics. And providing you like a, 1,000-mile view of the architecture that is oversimplified here, it evidently starts with collecting data from our fleet. So basically, data points hit our backend, and these data points are typically represented by an ID that corresponds to an autonomous vehicle, by certain event types that happen, like, for example, did somebody orchestrate some functions within a car, a context under which circumstances did that event happen, and a timestamp. Within our streaming platform, we do some local event data processing, where the data somehow ends up in a data lake for the historic data storage, and in the so-called Backend Shadow, which I will outline in later stages of the presentation. The Backend Shadow is basically a cache state of the current representation of the vehicle. Based on that, you can basically see here that every session or every journey that a user takes with this vehicle is basically something that is described by a start of the journey, by entering details into his navigation system, by setting his temperature, by doing some adjustments to the temperature, and so on and so forth. So we can, on a very fine-grained basis, understand what are the needs and the preferences of users, and use the ultimate results of our prediction models that are based upon machine learning in order to trigger actions in real time. There are two directions which are important for us as well. One is how do we deal with use cases that should run on board? Model execution at the edge is very important for us here as well. However, it comes at a cost, because I do not have the entire context in order to execute that use case maybe on board. So I need to basically make a trade-off analysis for the use cases, whether or not I basically sacrifice for latency and want to run it on board versus I have more context in the backend and want to trigger more complex actions here. When it comes to on-demand mobility, we've started with car sharing a long time ago. Actually, it was 2011. I had to Google that, I have to be honest. DriveNow has been incorporated in 2011, which is 7 years ago, which is tremendous. Who of you knows DriveNow? We will actually have a Slido, Paul. Very good. Okay, yes, heard about it? No. Okay, wow. That's good. We have a different sub-brand, which is called ReachNow. Both of these companies are wholly owned subsidiaries of the BMW Group, and with ReachNow, we've started to embark on new and different business models for BMW, also in the light of autonomous driving. Ride-hailing is one of the keywords here. Uber, Lyft are doing this for a long time. We've started with that last year in Seattle with a very small-scale pilot. We're scaling that out now, and in that context, evidently data plays a big role, because you need to understand where, when and how many customer requests we'll actually have, and their demand prediction is one of the fundamental building blocks of actually building a fleet that can act intelligently. For a fleet intelligence system, evidently high-level questions, like, for example, which vehicle should pick up the passenger and which path should the driver take are of utmost importance, and all these considerations must flow into a system where we want to optimize for price, for the estimated time of arrival, and for the service capabilities of our service. Let me outline a couple of other problems that we currently see with this kind of business model. Well, undersupply, it basically leads to an increased waiting time for customers. And if you see, like, for example, in San Francisco, you barely wait for your Uber to come around the corner, and every minute or so you're getting served with your request. So we need to be on par, or at least competitive in terms of service quality here as well. Oversupply, on the other hand side, will decrease the utilization of our fleet here, which leads to increased costs. So there's always like this balance that we need to find. And short and long-term demand prediction will ultimately help us to address the first point here, which is basically to match the supply with the demand distributions, and also ultimately shift the drivers from oversupply to over-demand regions, which is the ultimate goal with what we did over the last couple of months with Reach Now. Well, if you go about modeling a demand prediction problem, it's basically a geospatial problem. So you basically have geospatial dependencies. You need to carefully define which kind of zones, which kind of neighborhoods you model, versus you also have very strong temporal dependencies. And then in addition to that, you have a lot of exogenous variables, like, for example, weather, POIs, events that take place, like, for example, do the Seattle Seahawks play or not. They play a big role. And the model hierarchy typically boils down like this. On a city level, evidently, your prediction is super good because you can predict on a daily basis for the city of Seattle quite accurately what is going to be your demand. If you boil it down to different zones, which may be a collection of different neighborhoods, then evidently it gets more fine-grained, and ultimately you want to end up on a very fine-grained basis that takes neighborhoods into account. And besides that, as I outlined that before, the temporal dependency is also very important. So you want to model rush hours, you want to model not so much rush hours, and this is all considerations that we have to take into account here. We've built a decision front-end, and I happily invite you to our booth afterwards where we can actually showcase what we've built that enables the navigation, the querying, and the visualization of demand prediction results. And it enables technical and non-technical stakeholders to utilize the model results for decision making. And one of the conclusions that we derived here is that based on the ultimate insights that we generate, it's always important to keep the analysts and the humans here in the loop, and to feed the feedback actually back to the model building processes that we have here. This was one of the crucial learnings for us as well. There are certain gut feelings, there are certain factors which you may not be able to model beforehand, and that's why these kind of latent variables need to be included later on in the modeling stage. If we go into the broader ecosystem, evidently it also plays a role. How does, for example, car sharing compare to ride hailing? So if I have high demand in ride hailing, how can I outweigh that with things that I offer in car sharing? And here we are embarking on things like we want to suggest optimal pickup locations for the customer to actually reduce trip time and ETA. We want to do member marketing and loyalty, which is at the moment very rule-based. So you basically look at the historic interaction and you define which customers are most prone to not use your service anymore. You want to push marketing results to them, and that's very handcrafted. That's depending on a lot of expert knowledge, and we want to make that more data-driven. Car sharing demand prediction, of course, also plays a big role, although in comparison to ride hailing, you don't have these large levers that you can pull in order to be more flexible, because the only thing that you can do is you can rearrange your cars, which is costly, or you can basically increase the fleet size or decrease the fleet size, which is also costly, and you're not that flexible. Last point is service block optimization. So as you can imagine, if we have i3s, they're quite costly to service because i3, the range is roughly 200 kilometers. So you need to make sure that you always have a certain state of charge that customers actually are able to use these vehicles. One of the things that we've built as well, and you can see it on the right bottom part here, is the ATA estimator, which takes into account the sort of coverage that a vehicle, that a driver in a ride-hailing scenario can have. And this is one of the factors that, in combination with demand prediction, is actually pretty crucial in order to determine where do I actually put my drivers in order to be able to cover the future demand. We have a couple of demos for you prepared at the booth. Happily invite you again here to join us afterwards. The high-level architecture, and this is basically addressing the point that you've described before. So we have a couple of cloud hubs, and with the on-demand mobility services that we're building for Reach Now and Drive Now, we are very much heading towards cloud-based services. In that context, we are using AWS as the main backend here, and data integration of internal data sources happen primarily via Amazon Kinesis. Data integration with other third-party data sources such as events, poise, weather, holidays, happens via lightweight Lambda functions, and all data is then being made available via a big Redshift instance. Ultimately, it boils down that we have workflows set up in our data science environment that help us define the required demand prediction models that are being exposed via an API gateway to the decision front ends that you've seen before, and just basically shows the journey of how you actually go from historic data to real-time insights via API-based development for machine learning problems. Well, now I come to the Backend Shadow. I think I briefly mentioned it before. The Backend Shadow is a concept which we have started roughly 1 year ago, where we said, okay, well, we have a couple of traditional data sources, such as the vehicle master data, customer contracts, data privacy settings of customers, user settings, and so on and so forth, that we want to make available. And at the same time, we have very high frequent vehicle telemetry data that we stream process with Apache Flink and then dispatch on the one hand side to the existing data lake that Tobias mentioned before, on the other hand side to a document store that serves as the single point of truth for the cache state of the vehicle. The semantic API on top basically provides real-time access to these data sources. So first of all, to the traditional, more relational data sources like the vehicle master data, but also to the real-time data that is flowing in via the vehicle telemetry feed. Afterwards, you can have consuming backend microservices that consume, based on the historic insights, models that trigger actions based on real time on top of such a semantic API and trigger actions back to the vehicle. And I think this is a pretty reasonable flow, and we have found that this kind of concept for us makes much sense. The starting point of building up such a backend shadow is always the right ontology, and we found that if you carefully lay out which kind of concepts you want to model, then it's always easier to query afterwards and to ask to answer the right questions. So 2 points are important here. We basically defined attributes which are more the stateless attributes, like for example the vehicle master data, and then you have signals which can change very frequently. And with the signals, for example, you can have things like the vehicle speed, you can have the vehicle ambient temperature, you can have things like, for example, for the cabin infotainment, navigation system, you can have the longitude and latitude where the vehicle is currently operating in, and such a concept gives you a nice abstraction on top of data that you're able to query afterwards. So how does a query basically look like on top of GraphQL? It actually looks pretty simple. So you basically have a query that says, I want to query the speeds of vehicles by a certain location parameterization. So I basically define in my GraphQL query which kind of payload I want to receive actually before writing my query. So this is very different to a traditional REST endpoint where I say, give me the whole payload of the vehicle. I might not need everything of that vehicle. So this is always something that is something that you have as a drawback if you have traditional REST endpoints. And with that parameterization, I can actually pretty flexibly get the query, get the right answers to my question. And in that case, I have 3 vehicles around Hofburg-Wien which have certain speeds. And this is actually the answer I just wanted for my use case. And based on that information, you can trigger the actual results. You can speak with the vehicles, and you can trigger actions on top of that. Well, this already leads me to the conclusion. I think we are good in time, which is good. So we have more time for Q&A. I will briefly wrap up with a couple of challenges, which are as follows. First point is model interpretability. So there have been a lot of research going on in that area. There's this paper, Why Should I Trust You, from Ribeiro, Singh, and Gastrin. It's actually a pretty old paper where they've picked up on the perspective of how can we make predictive models more understandable. And I think this is one of the topics that we will more and more embark on in 2018 to actually move away from the notion of complex black box models towards having very interpretable models. And again, we have a demo for you at the booth, which shows some first steps towards that, of how we handle that within the demand prediction for reach now. I think this is an exciting topic for us. Second point is hybrid environments. So we have a huge discussion between on and off premise. I think it's always determined by the project's nature. Like, for example, with Drive Now and Reach Now, the nature was pretty clear, so we wanted to build up something in a very flexible and agile manner, and that's why we decided for cloud-native applications that we've built up inside of AWS. Sometimes it's just reasonable to actually make a total cost of ownership perspective beforehand, before actually decide whether it is on or off-premise. Device edge versus cloud edge, another topic for us that is of utmost importance. I've briefly outlined that within the voice assistant scenario. So you need to be careful about what kind of models you want to have executed on board inside of the vehicle versus which kind of things you want to have executed within the cloud. Third point, data curation. I think this is also, for me as a data scientist, a very, very important topic. Capturing metadata is very important, and the API of the vehicle shadow gave you guys an impression of how important it is to actually curate the data you are collecting. And with every kind of also traditional data sources, we are heading more towards actually documenting data sources, making sure that people understand what is being captured. And this is a very critical and also a very complex task across an organization such as BMW Group is. And automation, I think you've talked plenty of things about that. We want to have a lot of test coverage, a lot of automation. So everything that we build, like for example, in the cloud, we want to make as compatible as possible to be instantly deployed. And that's one of the things that we are looking forward to as well. Good. Then I think I'll wrap it up here and leave it to the questions. We have a couple of more minutes of time, which is good. Thank you.
Round of applause. Thank you very much. Thank you very much. I hope you asked lots of questions. I've seen some questions. I need to get my question in first, because I think a few people in the room will be thinking this anyway. What's it really like to work as a data scientist for BMW?
I think this is a question to me, right?
Yeah.
Okay. I mean, I was coming from Allianz, which is a very traditional company. We've been building up the data science branch there, and it was pretty exciting for me at Allianz as well, because Allianz is a very data-affine company. But then moving to BMW, I've actually discovered that especially vehicle telemetry data, as it has a very geospatial nature, is pretty interesting to work with. And I'm pretty happy so far. I hope to stay very long with BMW.
So you can, I mean, the sand pit, the playing field, it's pretty good?
Yeah, I would say so. So.
We've got a couple of questions in here that mention something like this. There's the one about the scandal. There's the one about, let's get it out of the way. Cybersecurity, sure. Security is kind of an umbrella above the whole thing. I mean, I assume with the GDPR, my BMW is going to say to me the next time I get in, if you want to keep driving this car after the 25th of May, you have to click here. So, am I wrong? I hate it. What about data security?
Well, I mean, I see two aspects in that question, right? So there's data privacy, which is more of a customer's perspective, and then there is data security, which is more of a backend component, right? If I talk about data privacy, we are heading towards more transparency within our cars. So we'll have, with the new generation of the BMW OS 7.0, which will be coming out this fall, we'll have a very transparent data privacy menu to actually give you, as a customer, the ability to see exactly which kind of data points we are tracking and how we are making your lives easier if we track that. I think that's one part here. That's
sort of almost the second question. That's
exactly.
Privacy.
Yeah, cool.
What about security, though, yourself? Because you're transmitting data from the cars to a zillion places around the world.
Yeah, so basically the answer of the question comes down to what data we're talking about. So of course you mentioned the data coming from the vehicles, which are really starting in the car, then going through an area which we completely don't control completely, and then going back to the backend, maybe to processing in AWS. So we ramped up recently our cybersecurity department, and yeah, the whole basically route the data is taken is completely secured.
He said completely secure. Okay, you can quote him on this.
When it comes to,
because I know what happened with Cambridge Analytica.
When it comes to basically some data, actually, and we have huge discussions going on. Can you have certain use cases, applications in the public cloud in an environment which you cannot control completely as a BMW Group? And there are for sure assets which we will only have on premise, so in our data centers where we have full control, where we can build security walls.
I think a German car manufacturer is certainly a different thing to a company that prides itself on creating profiles of voters, but we're in different terrain. Yeah. But that's why the questions come up. What about GDPR? Who does the data belong to?
So I think I briefly answered a couple of aspects of the question, but I think I can provide a second answer to the question as well. I think if we look at BMW 5 years ago, especially on all the companies of the automotive industry, 5 years ago people would have said, well, okay, I collect data, it belongs to me as a company, right? But this notion is more and more changing, and we are transferring the ownership of such data to our customers. So we, I think last year it was, we introduced the Open Telematics platform, which gives you as a customer the ability to actually, similarly to Facebook, Google, to download all the data points that you're generating with your car. So this basically proves that we are heading toward this direction. And
I think if you see the balance, the whole thing with GDPR was the same thing. You can track the shit out of me, right? But you have to give me something back. Yeah. And if you're just saying, yeah, but we've got like a communication tool and Gmail is great and this, that, and the other, that's not the same, because people get suspicious when they think my car is going to track me when I'm visiting my girlfriend, et cetera, et cetera. Or
not your girlfriend, right?
Yeah, well, precisely. Does somebody put a subpoena in and get the data in a court in a divorce? But let's not talk about my divorce. Let's get through a few more questions. My dear wife. What about the bottlenecks? What about the data collection itself?
Yeah, it again depends on what kind of data we're collecting. So as I said previously, we're getting data from SAP systems internally, from CRM systems, which can be in the cloud, which can be on-premise, getting data from the cars, from production, from IoT devices, completely different, and then all of them are collected differently, as you can imagine.
So it's so widespread, there's not one bottleneck, that it all comes in the front door and Munich.
But the bottlenecks, of course, are on the different routes. It starts with the SIM cards in the cars. Of course, you cannot, you don't have the bandwidth to transmit everything, and there are projects going on where you can basically control in certain points of time what data needs to be collected. And then we have bottlenecks, of course, when it comes to the test drives. And I don't know what the real number is, 20 to 30 terabytes per hour per drive. And the challenge here is to get this data very, very quickly into our servers.
20
to 30 terabytes per hour per drive. And what is done here is, you take the hard disks and plug them in differently and copy the data. So the I/O is really the bottleneck. And there are different bottlenecks in other.
Let's get this Tesla question out of the way. I mean, these are data scientists, but why was it necessary for Tesla to give the car manufacturers a big kick, and did they?
Well, now we could say we are IT folks. We do not have an answer to the question, but I think we have, right?
Yeah, we have one.
Let's try to answer that. Well, I think with the introduction of the i3 in 2013, we were the first movers of the German automotive companies that happened to have a pretty interesting, fascinating car. And I personally like it very much. I know it looks very interesting. Yeah? I don't know, people would agree with me, but every time I drive the i3, I think it's a great car, and we are heavily investing into.
He's being paid to say that.
Yes.
Right.
Yes.
Okay. Sure, it looks cute.
No, but we are heavily investing actually.
I mean, as an outsider, Tesla changed the discussion. People started talking about these things. Were you talking about these things anyway, and Tesla just made them public?
I think we are much too modest with the things that we did, and I think that's just a difference between Germany, Austria, all the European countries versus the things that happen in Silicon Valley.
I mean, there's 31 of you outvoted us, and somebody asked the question, is that what you think, crowd? Tell me.
And I guess that, in addition to the answer, is basically, I guess, and this is an internal perspective maybe, we are taking the right speed for this topic, because if you want to have 80%, 100% electric cars out there, you need to do different things as well. The infrastructure needs to be there and everything. And this is all not ready, and the customers are not there as well, I guess. So, yeah.
We're trying to use all the time. I like this question. Let's talk about this one. What about, I mean, they are young, aspiring data scientists, but what advice, I mean, like I said earlier, what kind of company is it to work for? What kind of advice would you give to aspiring data scientists at the beginning of their careers?
You want to answer that?
Sure, you're the data scientist.
Okay. What kind of...
Drink more
question.
coffee.
That's a good question. I think one of the things that happened to me was I joined Allianz after my master's studies, and I was confronted with guys who studied astrophysics and all the crazy shit. I was really like a little bit too modest at the beginning, I guess, because I quickly learned, I quickly took up on the topics they did, and sometimes it's really about having the right level degree of pragmatism and getting things done. And I think if you're proficient in Python or R, you can get things done quickly. And with all the libraries and ecosystems out there, for example, that Python offers, with a couple of weeks and months of research, you can be pretty proficient, and you can be on par with somebody who did his PhD in astrophysics and so knows more about string theory.
And it doesn't have to be a huge car manufacturer.
No, it doesn't have to be, but it can be.
No, I spoke to when I spoke to the data scientist from Cambridge Analytica. He's a PhD in astrophysics, and I said, "What did your colleagues do after university?" And he said they went to betting shops or King.com. The game developer made Candy Crush, so they either go to devise in-app purchases in bubble games, or they go to bet companies. And he said, "So I worked for Trump." So he doesn't have a bad conscience, because it's like Trump, betting, or bubble games. So.
Actually, if I may add something, so I had to take for myself the decision 3 years back which company I join now, BMW or one of the big internet players or others. And I guess at BMW, at an automotive, it is a lot of fun, because you can do this topic as broad as in no other industry. You can do marketing use cases, which you do in the finance industry maybe. You can do production, you can do autonomous driving, you can do everything on a scale which you don't see in many other companies. So.
We're going to have to wrap it up there. I really, really enjoyed it. Thank you very much, especially for the questions and answers at the end. Big round of applause, please.